Good evening, ladies and gentlemen. My name is Alex Russell, and I'm going to be starting off this evening by talking about pavement engineering. Before I get into it, though, I'd just like to clarify a bit about terminology. So these are what the English would call chips. These are what the Americans would call chips. This is an English trunk. This is an American trunk. English pants, not pants. This is what the English call the pavement, and this is what the Americans call the pavement. But actually, the Americans are right on this one as far as we engineers are concerned, because we call the road construction the pavement. And what I'd like to try and demonstrate to you that engineering is in everything around us, not just the kind of big, exciting projects you can see on screen there. So to do that, what I've got in front of me are two examples of pavements, one of a good and one of a poor one. And as Rob says, both constructed from cereals and various snacks. So every pavement starts with the existing soil, or the subgrade as we term it. In the example of the poor pavement here, we've got something that's very heavy in clay. So clay particles, whilst they're very small, they're shaped like cornflakes. So they have a large surface area, and this, coupled with the fact that they have imbalanced electrical charge, means they hold a lot of water. And what happens is over time that water drains from the soil, and the pavement overlying that collapses above it. So what we're looking for is something with a bit more meat to it, a bit more robust, so a range of soil particle sizes and free draining properties, like the grape nuts on the right-hand side. The next layer, to improve the strength of that subsoil, we put a layer of capping in. So what we're looking for is a dense layer with lots of different sized pieces of crushed stone and aggregates. So something like the granola on the right-hand side. What you wouldn't want is something like the cocoa rocks, if you've ever come across those, which are very rounded and all the same size. So there's poor tessellation and lots of voids in between those. So you get what we call migration of fines into that layer, which again means the overlying layers settle down into it. The next layer is the subbase. Again, this is it's a granular material to provide more strength. So in the good pavement example, we've got a flapjack here. So all of the oats in there, it's lots of different shaped particles, if you like, which represent the aggregates, and they interlock well to form a strong layer. What you don't want is the Rice Krispies, which are all very rounded, and under the loading of the traffic, they gradually slip against each other, again settling and disturbing the pavement over the top. The final layer is what we call the bituminous construction. So the good pavement here is made from rocky road. So there's four constituent materials in that. There's big bits of biscuit, which represent pieces of aggregate, which give the layer its strength. There's smaller crushed up pieces of biscuit, which are essentially bits of sand to fill those gaps and to make it dense. There are pieces of marshmallow in there. What they represent are pieces of rubber, or polymer modifiers as we call them, and that gives the bituminous construction some flex so that it can flex under the load. And finally, it's all bound together by something called bitumen, represented by the chocolate. In the poor example, there's lots of voids, which means it's very brittle and is potentially going to collapse. And hopefully to demonstrate that now, you can see the good pavement has barely moved. And that's what's happened to the poor one. Thank you very much.